As we are going through in the series of analytical equipments on our channel, we also like to cover compound microscopes, which is a part of every pathologist and pathology laboratory. In this video, we will look into the beginning of microscopes, the working principle of the microscope, components of microscopes, and the types of microscopes used in the medical field. Let's look at where it all began. Three Dutch spectacle maker, Hans Janssen, his son Zacharias Janssen, and Hans Lippershey have received credit for inventing the compound microscope about 1590. The first portrayal of a microscope was drawn about 1631 in the Netherlands. It was clearly of a compound microscope with an eyepiece and an objective lens. This kind of instrument, which came to be made of wood and cardboard, often adorned with polished fish skin, became increasingly popular in the mid-17th century and was used by the English natural philosopher Robert Hooke to provide regular demonstrations for the new Royal Society. These demonstrations commenced in 1663, and 2 years later, Hooke published a folio volume titled Micrographia, which introduced a wide range of microscopic views of familiar objects, fleas, lice, and nettles among them. Let's look into the principle of the compound microscope. Compound microscopes have a combination of lenses that enhance both magnifying powers as well as the resolving power. The specimen or object to be examined is usually mounted on a transparent glass slide and positioned on the specimen stage between the condenser lens and objective lens. A beam of visible light from the base is focused by a condenser lens onto the specimen. The object lens picks up the light transmitted by the specimen and creates a magnified image of the specimen called the primary image inside the body tube. This image is again magnified by the ocular lens or eyepiece. When higher magnification is required, the nosepiece is rotated after low power focusing to bring the objective of a higher power, usually 45 times, in line with the illuminated part of the slide. Occasionally, very high magnification is required, for example, for observing a bacterial cell. In that case, an oil immersion objective lens, usually 100 times, is employed. The common light microscope is also called a bright field microscope because the image is produced amidst a brightly illuminated field. The image appears darker because the specimen or object is denser and somewhat opaque than the surroundings. Part of the light passing through or object is absorbed. Let's learn about the components of the compound microscope. The first component is the eyepiece and body tube. The eyepiece is the lens through which the viewer looks to see the specimen. It usually contains a 10 times or 15 times power lens. The body tube connects the eyepiece to the objective lenses. The second component is objectives and stage clips. Objective lenses are one of the most important parts of a compound microscope. They are the closest to the specimen. A standard microscope has 3 to 4 objective lenses, which range from 4 times to 100 times. Stage clips are metal clips that hold the slide in a place. The third components are the arm and the base. The arm connects the body tube to the base of the microscope. The base supports the microscope and its illuminator. The fourth component is the illuminator and the stage. The illuminator is the light source for a microscope. A compound light microscope mostly uses a low voltage bulb as an illuminator. The stage is the flat platform where the slide is placed. The fifth component is nosepiece and aperture. The nosepiece is a rotating turret that holds the objective lenses. The viewer spins the nosepiece to select different objective lenses. The aperture is the middle of the stage that allows light from the illuminator to reach the specimen. The sixth components are the condenser, iris diaphragm, and the diaphragm. A condenser gathers and focuses light from the illuminator onto the specimen being viewed. The iris diaphragm adjusts the amount of light that reaches the specimen. The diaphragm is a 5-hole disc placed under the stage. Each hole is of a different diameter. By turning it, you can vary the amount of light passing through the stage opening. Let's end the video with types of microscopes and application. There are several different types of microscopes used in light microscopy, and the 3 most popular types are the compound, digital, and the USB computer microscope. Some types are best suited for biological applications, where others are best for classroom or personal hobby use. As we have already seen and learned about the compound microscope, let's look into the digital microscope. Step into the 21st century with a digital microscope and enter a world of amazing detail. The digital microscope, invented in Japan in 1986, uses the power of the computer to view objects not visible to the naked eye. Among the different types of microscopes, this can be found with or without eyepieces to peer into. It connects to a computer monitor via a USB cable, much like connecting a printer or a mouse. The computer software allows the monitor to display the magnified specimen. Moving images can be recorded or single images captured in the computer's memory. An advantage of digital microscopes is the ability to email images as well as comfortably watch moving images for long periods. The next type of microscope is the USB computer microscope. Although not well suited to the same scientific applications as other light microscopes, the USB computer microscope, among the different types of microscopes, can be used on almost any object and requires no preparation of the specimen. It is essentially a macro lens used to examine images on a computer screen plugged into its USB port. However, the magnification is restricted and is not comparable to your standard compound light microscope at only up to 200 times with a relatively small depth of field. The third type of microscope is the electron microscope. Electron microscopy, or EM, is a technique for obtaining high-resolution images of specimens. It is used in the evaluation of pathology cases for detailed examination of structure of tissues, cells, viruses, organelles, and macromolecular complexes. The high resolution of EM images results from using a beam of accelerated electrons as the source of illuminating radiation. These images provide key information on the structural basis of cell function and of cell disease. There are many types of microscopes that are used in the medical industry. We've covered most of the microscopes used in general day-to-day life in pathological use in this video. We hope you like this information on the compound microscope. If you did like it, please give us a thumbs up and subscribe.